Let's talk about chapter 6 in the Gaddis book. This would be about functions. So we've already learned about methods and modules. A function is a special kind of module, typically that has a return value. So let's jump into that. So we're going to talk about our writing our own functions, and then we're going to talk about library functions. So we've already used a bunch of functions, and we're going to we'll talk more about those. So a function is really just a module that has a return value. So when you talk about the input processing output loop in our code, a function will typically take input, will be received as a parameter. Sometimes it might read that input from the console or from a file, but generally it's going to come as a parameter. It's going to do some processing on it, and then the output of that function is going to be a return value. We'll actually have a return statement, and it will return data back to the calling method, where that data will then be used in some kind of process in the calling function, assigned to a variable. Maybe it's used in as a Boolean expression, whatever the need may be. So we can write our own. We also have library functions. So we've already used this. The scanner is a set of library functions. So when we create a scanner in Java, we do next line. That's us using a function inside a library, inside a library. So we've already had some example of that. We use the math functions, math.pow. That raises a number to a power. That's a math function. So that's built in. So we already have experience using functions. We just haven't necessarily called them that. Remember again that we will in Java, we will sometimes use the module method function term interchangeably. They do have some unique definitions, but most people will use them interchangeably. The language gets pretty loose there. Method is typically is going to be what you hear most, but method and function will be used interchangeably. Functions defined just like modules. They're defined exactly the same as module, only they have a specific data type. So when you declare a function, you have to say what kind of data is being returned, and then the compiler is going to enforce that you actually return that. And you'll use a return statement to end that. When you get to, so here's an example of declaring module main, and then we've declared this function. It's called sum. It takes two parameters, num1 and num2. We then declare the result, we do some math, and then we return. So notice that when we declared the function here, we gave it a return type of integer. So that means that our method, our method here is returning an integer data type. So anytime you call that method, we're calling it here on set total, and we're calling the sum function. That sum function is returning a value. And that's on the right side of our assignment statement. So then we assign the return value of that method to this total variable name. So total must be an integer data type and must match the return type of the method in order to be syntactically valid. Okay, so notice you can pass multiple arguments into a function, but you can only return one. If you need to return multiple pieces of data, you have to use a more complex data structure than a primitive data type, which we will not be doing in this particular week. But you only get to return one variable. So it can be a complex variable, but you can only return one. If you're doing flowcharts, you should flowchart functions separately, and you simply use a return statement. You would declare the return type in the definition. Here's some other examples of functions that are built in library functions: square root, power. We've seen that. The scanner, rounding functions, random number generation, all that kind of stuff is functions. And we get a lot of examples from math. We also use the data type conversion function. So we've done integer.parseInt. That's a function. So that the integer is a wrapper library for integer data type, and parseInt takes a string value and returns and converts it to an integer data. So we've seen those examples in action. We can also use functions to do formatting. So the system.out.print, that's a function. We can use printf, that's a special formatting function, which we'll learn more about. We can also use currency formatting. So if we want to format something as currency or do numeric formats using the appropriate thousand separator or currency symbol based on the country we're in, then we have built-in formatters built into our programming language, which help us do that use functions. They typically take the numeric data as an argument or parameter, and then they return string data that's been formatted. In this case, we're returning a US locale formatted currency using the United States $, a comma as the thousand separator, and a period as the decimal separator. You can define, maybe you're writing a program in Europe or France or Japan, in which case you could define a locale, which would, when you define your currency formatter, would use the appropriate formatting here. In European countries, they often invert the period and the comma when they're using currency, and then of course this would be the euro symbol or the pound symbol instead of the United States dollar symbol. Okay, strings have functions built in, so there's a wrapper class for strings. You can get length, you can append them, you can convert them to upper and lowercase. We've been doing that. You can parse them out. A string, you can take a substring or take text out of the middle of it. So all those functions are built in. The point here is that you can write your own functions, but there's a lot of functions already built into Java that are doing a lot of good stuff for us. Let's look at some Java examples of methods and functions. Here's the random number generation. So if you want to create random numbers, maybe you're writing a game and you need to generate random numbers, or simulating a rolling dice, card games, things like that. You want to use random numbers. You can generate those. Here's an example of calling it. In this case, we actually create an instance of the random number generator. Using this, there's a data type called random. This is a complex class, so like scanner. And so, but instead of reading data from the console or from an input source, it does random number generation. So you can create an instance of the random number generator, and then it has built-in methods next int. You can give it parameters for what the range of that integer might be, etc. So that's random number generation. Here's an example of us writing our own method. It's public static, but instead of void, we're actually using the data type int. So in this case, we have an integer data type. Sum is now a method that must return an integer data type. There must be a return statement coded in the method, and that returns that result. So when this return statement is executed, the method ends. So if there is code after this return statement, it will not be executed. You can also have more than one return statement, but only one of them will operate. So maybe you have an if statement in here, or maybe it's a while loop, and you put the return statement, maybe you have returned a different value based on some processing calculation inside the method. But you can only return one value. You can have multiple return statements, but only one of them will ever be executed. Once the return statement executes, the method ends, and the execution goes back to the calling method. Here's a more complex example. We've defined public static void main. We have a scanner. We're prompting to enter the age. We're using the built-in scanner function for next int. We then are calling this method sum to add the first age and second age, and it is simply adding them together and returning the value. This is obviously an overly simplistic example, really just intended to show the syntax of how you would write a function with a return type of int and then assign it to your variable. Here's another one that's doing tax. So in this case, we are using the currency formatter. So when we want to do currency format, and we'll do an example of this in a subsequent video. So in this case, we're defining a tax rate of 8.25%. We're asking for the meal cost. Then we're adding the meal cost plus the tax rate. And so in this case, we're calculating the total cost, and then we're doing the format. So in this case, we actually create a currency formatter object it's called a number format. This is the data type of the currency formatter object. And we say assign it to an instance of the number format.getCurrency instance. So in this case, this is using the default locale. We don't specify what country or what location we're in, so it uses whatever the location of your computer is, probably the United States. And so then that will use whatever the currency and currency formatting rules are for wherever your computer is located. Then we use a built-in method in the currency formatter called format, where we give it a numeric data type. This returns a string, and we see that our output would look like this, formatted with the $sign, a period, thousand separator if there are any to be had, and then 2 points of decimal precision. All right, we'll do an exercise in a subsequent video.